Before we dive into the statement, it's far more persuasive to sort out what molecular gasoline pedals are. The Big Hadron Collider, LHC, operated by CERN, is a 17-meter ring of superconducting magnets. In addition, it's the world's most prominent and most noteworthy atom smasher. It represents the pinnacle of human achievement. As a matter of fact, it's so powerful that it could reproduce the precise states of the first moment on Earth. But could the system intended to unlock the mystery of the universe hold the key to something truly specific? Founded in 1954, CERN is one of the world's most famous research institutions. With 23 member states and countless researchers, it's a place for collaboration and innovation. The LHC is CERN's principal undertaking, but it is only one part of a large organization of gas pedals and tests. Consider a route not so much for automobiles or people, but for subatomic debris. In a trial of aptitude, patience, and space itself, the LHC accelerates protons to almost the speed of light, sending them on a collision course that reflects the energy of the universe right after the Big Bang. The impacts create temperatures much hotter than the core of the sun. A large number of magnets guide the protons on their journey, while complex cooling structures keep the magnets at temperatures colder than space. The beams in the LHC are made to crash at 4 locations around the gas pedal ring, connecting with the spots of 4 particle detectors: Atlas, CMS Alice, and LHCb. Each fills a specific purpose, investigating different components of particle physics. Together they act as large cameras, taking pictures of these collisions. Scientists then sift through the debris, searching for signs of the elusive Higgs boson, also referred to as the God particle, and other anomalies that could provide clues about the universe's essential building blocks. By focusing on the microcosm, we gain insights into the universe. But with every solution comes another question, and with every discovery, another challenge emerges. The LHC is not just a scientific instrument. It's an exhibit of human curiosity and progress. It represents our entrepreneurial mission for knowledge and our desire to understand the key forces that shape our universe. But as we push the limits of what we know, we must also consider the more profound and existential questions that arise. What are the risks of probing the unknown? Could our quest for knowledge inadvertently unleash powers we have no control over? Within the sacred halls of CERN, where the boundaries of human knowledge are constantly pushed, a revelation has arisen that sends a shiver down the spine of even the most pro-scientists. Brian Cox, a former scientist at CERN and a voice of expertise in the field of particle physics, has recently said something that has left the world both enthralled and uncomfortable. Cox's words resound with chilling clarity. The purpose of CERN's Large Hadron Collider is to recreate a mini Big Bang. Yes, you heard that right, a small version of the very event that gave birth to our universe. The physicist also went on to explain the ramifications of this aim, highlighting the LHC's immense potential for making new discoveries. This includes its ability to uncover the secrets of the Higgs boson and explore dark matter, a mysterious substance that makes up a vast portion of the universe. Imagine holding the power of creation in your hands, the capacity to summon the very essence of the universe. It's an attractive possibility, but one fraught with danger. The mini Big Bang isn't just a theoretical idea. It's a very real phenomenon within the LHC. The temperatures, the pressures, the raw energy, everything recreates the conditions of the universe's birth. It's like standing at the dawn of recorded history, witnessing the birth of life itself. Yet with such power comes responsibility, and the question looms. What if something goes wrong? In fact, something did go wrong. Back in 1978, Russian physicist Anatoly Bugorsky encountered a disaster that would forever change the course of his life. While working on the U-70 synchrotron at the Institute for High-Energy Physics in Protvino, Russia, a failure caused his head to accidentally enter the direct path of a proton beam. The beam, with a force that defies perception, passed through his skull, entering the back of his head and exiting through his nose. Bugorsky's experience was harrowing. He saw a flash brighter than 1,000 suns, but had no immediate concerns. The beam's path left a trail of destruction, burning tissue and bone, but he remained conscious and even walked to the center for treatment. The outcome was both troubling and remarkable. The beam caused localized tissue damage leading to hearing loss in one ear and partial facial paralysis. Remarkably, Bugorsky's cognitive abilities remained intact, and he continued his scientific career. This incident serves as a reminder of the immense power and potential dangers of particle accelerators. The dangers of a particle smasher like the LHC are not to be underestimated. The potential for catastrophic reactions, the very fabric of existence being altered, these are not the stuff of science fiction, but real concerns voiced by respected scientists. One of the most unsettling and captivating concerns related to the LHC's experiments is the possibility of creating a miniature black hole. Black holes are regions of space-time where gravity is so strong that not even light can escape. They are giant vacuum cleaners, devourers of stars, and mysterious entities lurking in the shadows of our universe. The fact that the LHC could potentially create such a phenomenon, even on a small scale, is awe-inspiring to both the public and scientists alike. Could this black hole eventually grow out of control, swallowing the Earth from within? Scientists at CERN have reassured the public that any black hole created would be unstable and disappear very quickly. Nonetheless, the remote possibility has sparked debates, fears, and a sense of awe at the energy we wield. Some have taken the idea even further, speculating that the LHC's experiments could open a gateway to another universe or dimension. While this idea is largely dismissed by mainstream scientists, it has captivated the imagination of many and become a subject of intrigue, fear, or even fantasy. What lies beyond our universe? Could we accidentally unleash forces or entities that we don't understand? The idea of extra dimensions isn't new in physics. String theory, a leading contender for a unified theory of everything, suggests that there may be more than the usual three dimensions of space and one of time. Now imagine the LHC as a giant key opening doors that have been locked since the beginning of recorded history. Before we get too excited with wild speculation, it's important to remember that while the LHC is certainly powerful, there's no definitive proof to suggest that it will open a door to another universe, let alone to hell itself. Nevertheless, the allure of the unknown combined with the mysterious nature of quantum physics ensures that such ideas will continue to captivate the public imagination. So, should we be concerned about the LHC and its potential risks? It's easy to be swept away by sensational headlines and fears of global disaster, but the reality is that the scientists at CERN are highly aware of the risks involved. They've taken every precaution to ensure their experiments are safe and continue to monitor and test their work with the highest level of diligence. The Large Hadron Collider represents the frontier of scientific inquiry, where theoretical physics meets experimental reality. While most scientists remain confident about the safety of LHC experiments, there are undeniable uncertainties. What if new unexpected anomalies arise that challenge our understanding of physics and the laws of the universe? Regardless, the LHC's achievements in particle physics have been monumental. Yet the quest for knowledge remains one of humankind's most ambitious endeavors. The journey of scientific discovery is rarely without risk, and the LHC is no exception. As the LHC continues its groundbreaking experiments, it remains a beacon of scientific progress. Yet with each new discovery, the boundaries of human understanding are stretched further, raising more profound questions about the universe and our place within it. One of the most fascinating aspects of the LHC's research is its potential to reveal new physics beyond the Standard Model. The Standard Model is the theoretical framework that describes fundamental particles and forces, except for gravity. While it has been remarkably successful in explaining known phenomena, it does not account for dark matter, dark energy, or the asymmetry between matter and antimatter in the universe. Could the LHC uncover evidence of new particles, such as supersymmetric particles, which many physicists believe could solve some of these mysteries? Supersymmetry, SUSY, is a theoretical framework that proposes a partner particle for every known particle in the Standard Model. If these partner particles exist, they could help explain dark matter, a substance that makes up about 27% of the universe, yet remains invisible to direct observation. Additionally, the LHC's experiments might provide insights into quantum gravity, the elusive theory that aims to unify general relativity, which describes gravity on a cosmic scale, with quantum mechanics, which governs the subatomic world. Some physicists speculate that the LHC could produce microscopic black holes that would evaporate almost instantly, potentially offering clues about the fundamental nature of space-time. The search for dark matter and the mysteries of the cosmos. Beyond recreating conditions from the early universe, the LHC is also on a quest to identify the nature of dark matter. Unlike ordinary matter, dark matter does not emit, absorb, or reflect light, making it nearly impossible to detect directly. However, scientists believe it interacts gravitationally with normal matter, influencing the rotation of galaxies and the structure of the cosmos. If the LHC can produce particles that interact in ways predicted by dark matter models, it could revolutionize our understanding of the universe. Some experiments, such as those conducted with the ATLAS and CMS detectors, are searching for weakly interacting massive particles, WIMPs, a leading candidate for dark matter. Others are investigating the possibility that dark matter could consist of hidden sector particles that interact through unknown forces. A universe on the brink of revelation. Every experiment at the LHC is a step toward answering one of the most fundamental questions in science. What is the true nature of reality? Some theories suggest that our universe is just one of many in a vast multiverse where different physical laws may govern each reality. If the LHC were to detect evidence of extra dimensions or unknown forces, it could provide support for these radical ideas. Another tantalizing possibility is that the LHC might help uncover the nature of dark energy, the mysterious force responsible for the accelerated expansion of the universe. Unlike dark matter, which acts as an invisible gravitational pull, dark energy pushes space apart, counteracting gravity on cosmic scales. Understanding its nature could reshape cosmology and challenge our most fundamental theories. The ethical and existential implications. As the LHC ventures deeper into the unknown, ethical and philosophical questions arise. Should humanity be tampering with forces that we barely understand? Could our pursuit of knowledge lead to unintended consequences that alter the very fabric of existence? While the risks are minimal, the mere fact that such possibilities are being discussed underscores the immense power of these experiments. Some critics argue that scientific endeavors of this magnitude should be subject to greater public oversight, ensuring that safety remains the top priority. Yet, history has shown that the greatest scientific breakthroughs often come from pushing the limits of human curiosity. From the discovery of fire to the harnessing of nuclear energy, each leap forward has come with its share of risks and rewards. Looking toward the future. As CERN prepares for the next phase of the LHC, upgrades are already underway to increase its energy output and precision. The High Luminosity LHC, HLLHC, expected to become operational in the coming years, will enhance the collider's ability to observe rare particle interactions. With higher collision rates, scientists hope to refine their understanding of fundamental forces and potentially uncover new physics. Beyond the LHC, ambitious plans for even larger particle accelerators are being proposed. One such project is the Future Circular Collider, FCC, which could be 100 kilometers in circumference, nearly 4 times the size of the LHC. If built, it could push the boundaries of physics even further, probing energy scales beyond anything previously imagined. Final thoughts. The legacy of the LHC. The Large Hadron Collider is more than just a machine. It is a symbol of human ingenuity and our relentless quest to understand the universe. It represents the collective efforts of thousands of scientists, engineers, and visionaries working together to unlock the deepest mysteries of reality. Despite the concerns and uncertainties, the potential benefits far outweigh the risks. From uncovering the building blocks of matter to exploring the nature of the cosmos, the LHC continues to push the frontiers of knowledge.